This video shows all the solutions for number 6 using factoring. I also show alternate solution methods. Please pause the video if you need more time to see the solution. If you make y equals x squared plus 11x plus 24 and then graph it, where the parabola crosses the x-axis are your two solutions. This quadratic equation is more complicated to factor. Though it factors, you're probably better off to use GeoGebra to graph it. I have factored it for you and solved for the two values of a. The two values of a that solve this equation are a equals -4 and a equals 1.25. You can accomplish this using GeoGebra as well. Just remember that you must change that 0 to a y. In this case, y equals 8a squared plus 31a minus 4, and we need to change the a's to x's. Here I've graphed it, and you will see that the y-intercepts are exactly where we found them. This question isn't ready to factor yet. You must make sure that everything is equal to 0. So here I have reworked the equation so that c squared is positive and all the other variables and terms are on the same side as the c squared. By graphing in GeoGebra, we can also find the x-intercepts, and the x-intercepts are also at -1 and 6. Those two values make the y value equal to 0. Another way to graph this in GeoGebra is to treat the left side separately from the right side and have two different equations, y equals 5x and y equals x squared minus 6. Once you graph them, you're looking for the two places where the two graphs cross. This is similar to the situation where you graph two lines in grade 10 to find out where there was the one solution. In this case, you're graphing a line and a parabola, and you will get two solutions. I've changed the view in GeoGebra so that I can see the places where the two lines cross, and I've had to use the point tool to isolate where those 2 points are. Don't forget, GeoGebra, once you graph the two lines, will actually show you the exact points where they cross. Here's a really hard one to solve using factoring. So what I've done is graphed it. I have graphed the left side and the right side separately as two separate equations. Here's the first one graphed and the second one graphed. Where they cross is really hard to see, so I've changed the view so that I can isolate where the 2 points are. Be careful when you interpret your results. When you do find the coordinates of the intersection, it is only the x values that you want. So the solution is x equals -0.4 and x equals -0.25.